Hello everyone, you are welcome to another session of Python for All. In this video, we will talk about functions in Python. Here we'll look at what a function in Python is and also the type of functions in Python with examples. Let's get started. A function in Python is a block of code that performs a specific task. Functions are defined using the def keyword. The syntax for defining a function is you have def followed by the function name, which is also known as the function header, and then followed by in parentheses the parameters, also known as the input arguments, and then followed by a colon. And right after that, on the next line, you have your docstring, which could be a one-line docstring or a multi-line docstring, which begins with triple quotation mark and ends with triple quotation marks. Then followed by the body of the function, also known as the main body of the function. And after that, a return value. Let me state it here that not all functions return value. Some functions do not return any value. So when a function has no return keyword, it means that that function returns no value. In other words, returns none. There are four types of function in Python. The first of them is known as the built-in functions. These are functions that are built into Python programming language. They are available to use without having to define them first. For example, the print, string, list, dict, mention them, counter, and so on and so forth. There are so many of them. You don't have to define these functions. They are already built in into the Python programming language or the Python interpreter. Next is the user-defined functions. These are functions that are defined by the user. They can be defined to perform any task that the user wants. For example, the factorial function. Yes, we have seen the factorial function in our previous videos. That particular function we saw then is the user-defined function. Next is recursion function or recursive functions. These are functions that call themselves. They are useful for solving problems that can be broken down into smaller and smaller problems. For example, the Fibonacci sequence can be calculated using a recursive function. So the process in which a function calls itself is simply referred to as recursive call or recursion. The last here, but not the least, is the Lambda functions. These are anonymous functions. If you are from MATLAB programming paradigm, you understand what my anonymous functions. Okay, these are anonymous functions and they are defined using the Lambda keyword. Lambda functions are often used for short one-line functions. So when you want to have your functions in one line and very short, you use the Lambda functions. Let's start with the first one and look at examples and discuss them in details. First, built-in functions. Here I show an example with the print function. Here it prints hello world. So here let's print hello world. To do that, I will run this cell. If I run this cell, it gives me hello world. That's the output printed. The next is the user-defined functions. And to do that, we'll use the Fibonacci sequence as an example. Here we have the Fibonacci sequence, which is shown as 1, 0, 1, 1, 2, 3, 5, 6, 13, 21, and 34. Actually, the Fibonacci sequence starts with two elements or two items, 0 and 1. And the next item is the sum of the first preceding two items. So the next one, which is the third, is the sum of 0 and 1. The next, which is 2, is the sum of 1 and 1. The next, which is 3, is the sum of 2 and 1. So the next element is the sum of the preceding two elements. So we can abstract that as f of n equals f of n minus 1 plus f of n minus 2. Haven't done this abstraction, then let's write the function. So we start here by using def keyword, and the function header or function name is Fibonacci, and it takes parameter n, where n in this case is the index of the number in the sequence. In other words, I mean the position of the element. So n starts from 0 until, okay, until n. So now going to the body of the code, having written the docstring, if n is equal to 0, if it's the first item, which is 0, mind you, I know that we at this point uh, can recall that Python indexing starts from 0, not 1. So if n is equal to 0, the first element return 0. L if n is less than 2, not more than 2, okay, return n. Then else, then return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Now I'm calling the Fibonacci function itself. So the function is calling itself in the return statement. I run this cell, I already have, if I run this cell, I have my function in my namespace. So let's print the Fibonacci of 20. If I run this, it gives me 6765. But this only returns the Fibonacci of the element of that index. In other words, if the index is 20, the element or at that index is returned. What if I want to return the full sequence? Okay, this is just for, example. Then I need to write another function which I'll call fib sequence. So fib sequence will take also the index n, but in this case it will return the full Fibonacci sequence from 0 until n. So then I start with, I want to print it out. In this case, this function I see has no return statement, rather prints out the result. So I have print the Fibonacci sequence of the number, that's the dot string. I'll say print Fibonacci sequence, okay, and then end equals my quotation marks, spaced quotation mark. All this means that I print Fibonacci sequence and its output on a single line separated by a space. That's what it means. Okay. So now for me to print that, I have to loop through the indices. Okay. So for I in range n, normally there are two ways you can write this loop. I will explain that. I'll write the first one and I will run the second one. So let's say for I in range n, print the Fibonacci of I and n is equal to comma end uh, spaced. In other words, print all the Fibonacci of all the indices on a single line. But I wanted to print, I'll run this now, run this. I have it in my namespace. Now I want to print the Fibonacci of 20. But you notice here that I specified 21. Because the range function begins with the start but stops at an index or at a number which is one less than the stipulated stop value. For example, if you find the fib of 21, my range of n, my range function will take 0 until 20, but not 21. So if I run this, you will see what we have. It actually gives us Fibonacci of 20. You can see the 20th element, not the 21st. But another way of correcting this, if so that the users may not even know what to do, so I can take care of this for the user. All I need to do is to come back here and put n plus 1 in this point here. So I want the range of values to start to end at n. So I add 1 to it because the range function actually stops at n minus 1. We'll see that in our next video when we talk about the range function. So I will run this cell again. Okay, run this cell, and in this time around I will simply specify 20, the exact index I want to get the Fibonacci sequence. If I run it, what do we have? Same results, because I've taken care of it right inside the function. So having said, I'll move to the next, which is recursive functions. An example of a recursive function is the Fibonacci sequence we just looked at. So you see right in here, inside the Fibonacci function, you see the Fibonacci calling itself right in the same function. So that's an example of recursive function. We will see more examples subsequently, and also when you begin to do your own practical implementation, you will come across writing recursive functions. The last but not the least is the lambda function. Okay, if I have a function f of x equals x squared, I can decide to write my function using the normal def keyword followed by the function name and input argument x, and it returns x squared. Okay, but if I want it as a one-liner in the short form, I can simply use the lambda function. So here I have f underscore x, which is f of x, equals lambda x, and what it returns, I'll put it after the colon, which is x squared. Let's run this cell. We have f underscore x, which is f of x in our namespace. Let's evaluate f of 12, which you know should be 144, and let's see what the result it gives us. It gives us 144. Now, let's look at the second example here where we have f of x equals x cubed minus 5x squared plus 2x minus 4, and g of x equals 2x. Let's evaluate f of 4, g of 3, g of f of 2, and f of g of 2. Here we are looking at function of function. You're calling a function in another function, but we want to use lambda functions to demonstrate this. So to do that, we define the two functions. Lambda f equals lambda x, x cubed, minus 5 times x squared plus 2x minus 4. Okay. Define g of x, which is 2 times x. And then we run this cell to return, to have it in our namespace. So f and g is in our namespace. Now let's print f of 4, gives us minus 12. Print g of 3. We are calling the lambda function and specifying the input, the value x. Next, let's print g of f of 2. In other words, we substitute 2 into f of x. The returning value is substituted again into g of x. If we run that, it gives us minus 24. Then let's print f of g of 2. In other words, substitute 2 into g of x. That gives us 4. And then substitute that value, the return value, into f of x. What do we have? If we run the cell, it gives us minus 12. And you can see that f of 4 is minus 12. And g of 2 is 4. Okay? When substituted into f of x, it is what? F of 4, which is what? Minus 12. Now, let me state here that we can also define, let's say, a function h of x, that a lambda function h of x that takes two input variable. So let's say x and y. We define that simply with, on the one liner, with separated with a comma. Let's say and z. Okay, and then put a colon. What should it return? It should return x squared plus y squared plus z squared in the right spacing. Now this is our function. We run this function. What do we have? We have it in a namespace. What next do we do? Let's simply find print. Now I want to print h of, say, 2, comma, minus 1, comma, 1. Close it. If we run this, return 6. And that's 2 squared plus minus 1 squared plus 1 squared. That's 4 plus 1 plus 1. That's 6. I think you get it. So there is no restriction to how many variables you can pass to the lambda function. However, you are encouraged not to write too many lambda functions. But at certain times when you are developing a code, you can use lambda functions to do your testing. But it's not always advisable to do that. But this is just an example how we can use lambda functions. Also, we define uses in so many places, so we can always do that. Now, the next which we are going to talk about is the printing format, or what I'll refer to as formatting strings in Python. And so to do that, first I would, here I'm calling the print function, and I'm passing in a string literal, which is this is Python function tutorial, into the print function. If I run this, what do I have? It gives me this is Python function tutorial. So in other words, you can print using by just passing what you want to print, the string literal or your output variable or your function directly into the print function. That's one way of doing it. A second way, which is one of the oldest method, is using the percentage symbol. So here you have a percentage symbol in the quotation mark followed by the formatter. I would give examples that you understand what I mean by this, and then ends with the after the quotation mark, you have a percentage symbol, and in parentheses, what you want to print. Okay. The third method here is to use your brace bracket dot format. We call it the dot format method. Okay. And the last method is the f string method. I always like to use this last method, which is the f string method. Actually, when I started coding, I started with the first two method, and then gradually I moved to the third method, and now I use the last method simply because of it improves readability. So let's look at it now. In this example, let's say print Fibonacci of 6. Okay, I'm using just the first method here because I'm passing in a function which outputs a value. So if I run this, it gives me 8, which is correct. Next, I want to reprint this again and send a print here. In this case, I use the percentage symbol. Fibonacci of 6 equals percentage but g. This g here means return an integer from a whole number. And after the closing the quotation mark, I apply a percentage symbol, and then in the parentheses, what I want to print. If I run this cell, what do I have? It prints Fibonacci of 10 is 55. Now I can reprint this cell and change this formatting pattern and say print it to one decimal place. I put 0.1 F. I've changed the formatting pattern, delete this. Let's run this cell again. If I run this cell, can you see it returns 55.0? So that's the formatting method pattern I mean, or formatting style that I mean. I was referring to in when I talked about it here in this listing. So let's return it back to G because I want whole number, and run the cell again. It prints 55. Next is to use the dot format method. So here I'll say Fibonacci of 6 equals, put in your brace bracket, close the apostrophe, dot. The dot must come after the quotation mark. Format and then what you want to print in parentheses. If you run this, gives you Fibonacci of 6 equals 8. The last is using the F string. The F string begins with an F before the quotation mark. So I'll just put in my print F quotation mark Fibonacci of 6 equals, then you pass in what you want to print in the brace bracket and close the quotation mark. You can see that it's not more or less different from the one what we just did in cell 22, but it looks more nicer and neater. So I run it, same result. Fibonacci of 6 is 8. So you can use this method. In like manner, I will show you how you can print more than one output value using the dot format and the F string. So let's look at this example. Age is 30 and the name is John. So I say print my name is brace bracket and I am brace bracket years. Dot format. Now I want to print name and age. So you pass in dot format name, comma age. If you want to print more than 2, you pass them in into the parentheses of the dot format and make sure you have the same number of brace bracket already specified inside the quotation mark. So if I run the cell, what do I have? My name is John and I'm 30 years of age. The next is print. My name is name and my age is age. Yes. In this context here, we're still using the dot format method, but we're using the named keyword. In other words, when I put dot format name, I'll pass in the keyword of that name, the named keyword, which is name, age is age. You are permitted to do this. Okay. If I run this again, same results. And the last is the F string. So I say here print F, my name is name, and I am age 30 years. You see, this last method is not different from what we have in cell 24 and cell 25. But you can see how shorter it is, cleaner, and readable, much more readable than the longer dot format method. If I run this cell, return same again, my name is John, and I am 30 years of age. Yes, with this, we have come to the end of this video. Please like this video, share this video, subscribe to my channel if you have not done so, and do not forget to click the notification bell to get notified of my new upload. Until then, I'll see you in my next video. Bye.